Question number 27 of LPP linear programming practice 1. Okay, so the question is like maximize z is equal to 62,000 x1 plus 1,24,000 x2 subject to the constant 3x1 plus 4x2. 3x1 plus 4x2 should be less than or equal to 260. x1 should be greater than or equal to 2, then x2 should be greater than or equal to 3, then x1 and x2 should be greater than or equal to 0. So first of all, you should understand the numbers given in this one. Okay, first of all, you should understand the numbers given in this one. Okay, so it is saying that maximize z. Okay, so it's clear that it is a maximization problem. LPP model can solve maximize as well as minimize problem both. Okay, so what it's saying, maximize z, and how to maximize? By producing x1 number of units of some product and x2 units of some product. And if you are producing x1 unit, if you are producing, for example, here having one second. Yeah, for example, I am having so for example, my company can produce A as well as B, two products I can produce. So what I am saying, I have to produce these 2 units, but I don't know in what ratio I should produce these 2 units, because A is giving, if I am producing A, is giving 62,000 worth of contribution, and this is giving, if I am producing B, it is giving 1,24,000 worth of contribution. Okay, so see, this problem is saying produce x1 number of produce x1 number of A product and produce x2 number of B product, so that you can maximize the contribution. Okay, in which if you are producing x1 number of A, for each x1 it is giving 62,000 worth of contribution, and for each unit of B it is giving 1,24,000 unit worth of contribution. Okay, so but this thing you can do, but there are some constants. It is saying subject to 3x1 plus 4x2 should be less than or equal to 260, and then x1 should be greater than or equal to 2, x2 should be greater than or equal to 3. Okay, so wherever there is a more than one limiting factor, then only LPP will come into picture. Otherwise, if only one limiting factor is there, then that problem can be solved by marginal costing itself. Okay, so see how many limiting factors are there, 1, 2, 3. Okay, this is basic thing, this will always be there. Okay, how you can explain is this one is like, for example, the question is not maximum, for example, question is minimize. Okay, question is for minimizing the cost. Okay, suppose it's a cost, not contribution. So question is about minimizing. So what we can say is like, how we can minimize the cost? So maximum we can minimize the cost is 0. So what we can say, we will produce 0 units of x1, 0 units of x2. Obviously the cost will be the minimum, but there will be constant, always there will be this constant in every problem, and that will be greater than or equal to 0. That says you you derive at whatever ratio, but in that ratio you have to, x1 should be more than 0, x2 should be more than 0, means some unit you have to produce. That's why this constant is always there in every question. Okay, that's it. So you understood the question now. First step in any linear programming problem is like inequality. We have to convert the inequalities into equalities. Okay, inequality means what? See, this LHS is less than RHS, that's why it is less than or equal to, right? And this LHS is greater, more than RHS, that's what it is greater than or equal to 2, just like that this also. So what we have to do, first we have to break this inequality and make the things equal, make both the sides equal. Okay, so see, don't see this, don't see this is objective function. Okay, don't see this first, this is constant function. First see the constant function, how I am making it equal. So see, 3x1 plus 4x2, if I add one surplus variable, sorry, one slack variable, then it will become equal to 260. Okay, because if I add something this side, it will become equal to this one. Okay, just like that. See, x1 minus s2, just don't see this a1 a2 as of now. x1 minus s2 is greater than, sorry, x1 minus s2, I made it equal to 2. Okay, but if I am just taking the things just like this, it will create problem in this simplex table. How it will create problem is because when we are selecting this thing program. Okay, if I say now you will get confused, so okay, leave that, I'll tell you when we'll reach here, that time I'll tell you. Okay, so just listen to the procedure now. Okay, so what you have to do, x1 minus s2, when this is a surplus variable. Okay, because this side is more, no, so there is a surplus, so we will just deduct minus s2. Okay, so we'll just add a1 is nothing but artificial variable. Artificial is nothing but it's just imaginary, means it is not actually, it is not there, whereas s1 and s2 are actual variable. s1 is like slack variable. Slack means some idle resources. For example, I am having 10 kg. Okay, so suppose here I have used here 3 kg. Suppose I have used here 4 kg. So how much I have used? 7 kg I have used. 3 kg I am keeping idle. Okay, then it will equal to 260. So that means in reality this variable exists, just like that surplus variable. Slack, this is slack, this is surplus. So just like that, this surplus variable also in reality exists, but artificial variable does not exist in reality. Okay, so even if you are keeping it here plus a1, it will not affect the inequality or equality. Okay, this we are adding just to facilitate the simplex table so that we can proceed. Okay, so that's it. Now we'll go to the our first table. One second. Okay, now we'll go to our first table. So see, columns are FR program. This is FR means fixed ratio. Okay, FR program profit quantity x1 x2 s1 s2 s3 a1 a2 RR means replacement ratio. Here some different name will be there. See, everything is same only, but they have presented it in different way. This minimum, they are saying minimum ratio, nothing but replacement ratio. Okay, that's it. Everything is same only. Okay, now see, first thing what we do, just imagine that this suppose nothing is there. Just see this FR program profit quantity x1 x2 s1 s2 s3 a1 a2 RR. From where I got all these things and all. FR fixed ratio, that okay, once again. Okay, so these are the columns. Okay, so see, fixed ratio will be there. The program is nothing but the basic variable which we are going to take. so obviously that we have to take. Then for that basic variable, if you are having that basic variable, if you are using that basic variable in the what we say business, what will be the profit for that? Okay, so how much quantity you have to use for that? I mean, how much of the quantity of that variable which you are using in the business, how much quantity you have to use, that quantity will come. Then this x1, x2, s1, s2, s3, even it is nothing but this. Oh sorry, I forgot to tell this thing. Okay, so this thing you have done, you have understood. Okay, so this is the objective function. Objective function is like 62,000 x1 plus 124,000 x2 plus, now see, s1, how many things we have incorporated? This s1 incorporated new, s2 incorporated a1, sorry, s1, s2, a1, s3 and a2. Okay. So see, we have to maximize z, and how we have to do? By producing x1 units of x1 number of units of some product and x2 units of some product, plus if we are keeping something idle. Okay, suppose if we are keeping something idle, no, the revenue will be 0, that's why plus 0 s1 plus 0 s2 plus 0 s3. This a1, the artificial variable, we have to, because it is a maximization problem. Okay, so for maximization problem, just because this a1 or a2, this artificial variable should not be selected in any way, that's why we will allocate the highest cost for this. So minus m, that's why we are allocating minus m to this, minus m a1 minus m a2. Okay, so that's it, this thing, the objective function. Okay, that's it. So we'll come to this simplex table. So understood up to here, FR, fixed ratio, program, profit, quantity, x1, x2. Okay, so I was telling how all these things came. x1, x2, s1, s2, s3, a1, a2. Okay, the RR replacement ratio, we require this replacement ratio to select which one to come, which one to go out, like that. Okay, now see, first thing what we do, just see this portion from there to here. Okay, what is the coefficient of constants? Coefficient is nothing but, see, these things are there, no, this is coefficient and this portion is variable. Okay, so what is the coefficient of constants? That coefficient first you have to write down. So see, 3 constants are there, no, that's why 1, 2, 3 lines. Okay, these things and all just ignore this, whatever I did in pencil, that one ignore. Okay, just because it's 3 constants are there, 3 lines. If it had been 2 constant, 2 lines, 1 constant, 1 line. Okay, 1 constant will not be there, because if 1 constant, we can solve it by marginal costing technique itself. We don't have to come to LPP itself. Okay, so we'll start. See, coefficient you tried for x1 3, okay, x2 4, s1 1. In this thing only, when we are writing for this constraint, just you have to see this constraint only, you have to fill till end. So see, s2 is there, not there, that's why 0. s3 is there, not there, that's why 0. a1 is there, not there, that's why 0. a2 is there, not there, 0. Okay, that's it. Up to here only, you see, up to this thing only. Okay, now coming to the second constraint. x1 is 1, x2 is there, not there, that's why 0. s1 is there, not there, 0. s2, what is s2? Minus 1. s3 is there, not there, 0. a1 is there, yes, a1 is there, 1. a2 is there, not there, 0. Okay, just like that for a2 also. x1 is there, not there, 0. x2 is there, 1. s1 is not there, s2 is not there, that's why 0 0. s3 is there, -1. a1 is not there, 0. a2 is there, 1. Okay, one second. Okay, so what else doing? Okay, so this 3, for all the 3 constant we have written the coefficient from here till here we have written. Okay, see, this portion we have written, this portion we have written from this. Okay. Now next thing what we have to do, we have to see which one is forming unit matrix. So see, unit matrix is nothing but, see, if suppose some number is then 1 0 1 0 1 0 0 0 1 something. If it is forming like this one, that's called unit matrix. Okay, it need not be 1 0 1 0 1 0 0 0 1. It will be any form, 0 0 1 or 1 0 1. In any way, if it is like this, no, it is said to be forming unit matrix. Okay, so see which one is forming. This one, 3 1 0, no. 4 0 1, no. 1 0 0, okay, this one is forming, so keep that in mind, s1. This one, 0 -1 0, no, minus has come, rejected. 0 0 -1 minus came 0, rejected. 0 1 0, okay, this one is forming. 0 0 1, okay, this one is forming. So in this line, which one is forming? s1. 1 is there, no, this one is forming, so s1 came in the program column. And in this line, a1 is forming. Okay, so a1 in this line, a2, which one appeared in the program column. Okay, so now what I said that I'll explain it here is, see, if I had not done this plus a1, then this, 1 second. Okay, if I had not done this a1 here, no, what would have happened is this quantity column. See, okay, first we'll start from s1. See, s1 is there. How we have to select the quantity? This constant is there, no, other than s1 you denote other things as 0. For example, this also you think as 0 0. So what will come? S1 is equal to 260. So 260 has come. Suppose this a1 and a2 I had not brought here, then what it had been? If I had taken this x1 as 0, so it had been like minus s2 is equal to 2, means s2 is equal to -2. So the quantity would have become -2. That's why, just to avoid that minus signature, just to avoid that minus sign, we have to incorporate this a1 and a2. Okay, because if in beginning itself minus comes in quantity column, we cannot proceed. That is the rule of LPP. That's why this a1 a2 has come. Okay, so we got this is s1 a1 a2 quantity we got. Now we have to see how much profit we are getting. S1, see, we have to see this in the objective function. If we are having S1, how much it is giving? It is surplus variable, sorry, slack variable, so 0. If we are keeping everything idle, what will get? Nothing will get. That's why 0. And if we are having A1, it's giving minus M, highest negative, highest loss. A2, highest loss. Okay, so that's it. So all these things to taken. Now we have to see, now we have to find out the CJ. CJ is nothing but the relative contribution. Okay, for all the things. So for all the things, what is the relative contribution? So x1 62,000, x2 124,000, s1 0, s2 also surplus or slack, whatever it is. If you're keeping it idle, it will be 0. So 0 0 0. Okay, a1 minus m, a2 minus m. Okay, that's it, done. Now EZJ is nothing but, see, this x1 is there, no? X1 and profit column, these two you have to see what you have to do. This profit, for example, S1, just see 0 into 3 plus this minus m into 1 plus minus m into 0, the total of that you have to write here is it. Okay, so first one, one second, what happened? Okay, so got it right. Just here to multiply, one second, don't see this, okay, don't see this, okay. So you to profit and x1, for x1 you have to take this ZJ, no, this ZJ you take for the x1. So what you do to this into this plus this into this plus this into this plus the total will be written here before ZJ. So see 0 into 3 0 minus m into 1 minus m into 0 minus, so that's why minus m. Okay, like this for all you have to do like this only. Okay, then after you have to do Cj minus Zj. This is also called NER, means net evaluation row. This is also called NER, that is net evaluation row. Okay, in this what you have to do, Cj minus Zj. So see 62,000 minus m. Okay, this is already in minus m. What you have to do, Cj minus Zj. So 62,000 minus m, so it will become 62,000 plus m. And this one 1,24,000 minus m, so 1,24,000 plus m. And 0 minus 0, yeah, 0, and 0 minus m, 0 minus m minus m, minus m, it will become 0, minus m minus m, it will become 0. Okay, that's it. So whole table is completed other than RR and FR. Okay. Now how we have to select, like which one is incoming variable? We have to see, always we have to decide based on this NER row, or you can say Cj minus Zj only. So which one is highest? Because it is a maximization problem, it will not be final until and unless this NER row becomes 0 or negative. For maximization it should become 0 or negative, for minimization it should become 0 or positive for it to be final. Okay, so see which one is highest. This one is highest, 1,24,000 plus m, so means this is incoming variable. Okay, this is incoming variable. So go up, just mark it. This is key, what we say, the column, this is key column. Okay, I'm getting confused always in column and row. Okay, so this is key column. Now key column we got. Now we have to find out which one is this is incoming, we got it. But if somebody is coming, one has to go out, right? Because only 3 places are there. If one is coming, one has to go out. So we got that x2 is going to come. So who is going to leave? That we have to decide by replacement ratio. And how replacement ratio will come? This key column we got, no? So based on that we have to find out the replacement ratio. So quantity divided by key column will get the replacement ratio. See. So 260 divided by 4, 65. Okay, that's why it's taken here. It's not coming clear. Okay, that's why it's taken here. So 2 divided by 0 0, 3 divided by 1 3. Okay, so see we have to take the least positive number. Okay, least positive number. So you will say that okay, least positive number is 0. Why we have not selected 0? That is because we have to replace something. Okay, if we are selecting this, it is replacement ratio is 0, so it means nothing will get replaced, so something has to be replaced. That's why we are selecting this. Okay, so we selected this. So which one we selected for outgoing? A2. This one is incoming, this one is outgoing. Okay, so mark this. This is key row, this is key column, this is key row. Okay, and where it is intersecting now, this number, this is called key number. Okay. Now fixed ratio, how we to find out fixed ratio is 1 second. Okay, so what I was telling, the fixed ratio is there, right? Fixed ratio, how we to find out? Fixed ratio is equal to key column number, this is key column, no, key column number divided by key number. So which I said key number, this is the key number, so key column number divided by key number. So 4 divided by 1, 4, 0 divided by 1, 0. Okay, so the one which is going out, that outgoing variable, for that you don't have to calculate, you don't have to find out fixed ratio, just put a dash. Okay, that's it. So first table is ready, and it is suggesting us to proceed for further improvement. It is saying bring x1 and send a2 out. Okay, so now we will go to the second table. Okay, but second table, how we will make it? See, second table, how will make it? This columns will be same only. FR program profit quantity x1 x2 s1 s2 s3 a1 a2 rr. Okay, then next thing in this one, first thing what you have to do, first thing you have to keep in mind is like in new variable is easy, continuing variable is difficult. Okay, just for remembrance sake, like new variable will be easy for calculation. Okay, whereas continuing variable will be somewhat difficult. Okay, so new variable which is going to come, x2 is going to come. So see, this is going to leave, no, so on its place which one is going to come? x2 is going to come. So see, s1 is still remaining, a1 is still remaining, a2 left, and x2 has come. Don't see all this thing, this thing that this all thing is blank as of now. Just see program column. Okay, x1 is continuing, a1 is continuing, x2 is the new variable. So what I said, x2 is new variable and new is easy. Easy means what we to do? This column is there, no, this one. So what you to do, just see this one, this what to say, this row. Okay, this row is there, right? This row divided by key number will be the value of the new variable. So see, three divided by 1, 3, 0 divided by 1, 0, 1 divided by 1, 1. So see what is coming. So see 3, 0, 1. So up to here you got it, right? So see again 0 divided by 1, 0, 0 divided by 1, 0, then minus 1 divided by 1, minus 1. Okay, so see. Okay, so hope you got it. So like that, just you have to do what you have to do for new variable, the one which is leaving on that key row you have to select. Sorry, that key row you have to select, that key row number divided by key number. Okay, from quantity till a2, for all you have to do. Okay, then you will get this. Okay, that's it, you got it for x2. Okay, now this profit will be nothing but same thing we'll find out in the same way. S1 we saw, now it's giving 0 profit. For keeping item it will give obviously 0. A1 we allocated highest loss, so minus m. For x2, follow the objective function x2, for each introduction of 1 unit of x2 it will give 1,24,000. Okay, so 1,24,000 profit. Okay, so we got program column, we got profit column, we got, and this new variable we got. But continuing variable, what you do, how you do find out? For that there is a formula, a minus b formula. Okay, a minus b formula. See, a and b is there, so nothing, very simple. Because three variables are there, so first we have to for one variable we have to find out one by one. So first we will find out for s1, then we will find out for a1. So first I found out for s1, then for a1. Okay, so a minus b is nothing but what we have to do, just, so for example s1 is there, no, just go to the previous table. S1 is there, whatever quantity, whatever numbers are written before S1 from quantity till A2, 260, then 3, then 4, 1, 0, 0, 0, 0, just like that. Write down 260 and 3, 4, 1, 0, 0, 0, 0. Okay, so A you got it like that. Then B is fixed ratio into key ratio. So see, go back to the first table, fixed ratio into key ratio. So for S1 you are finding out what is the fixed ratio of that, 4. What is the key row? Okay, so fixed ratio into key row. So 4 into, multiply with each number. Okay, so for example 4 into 3, 12, 4 into 0, 0. So see, 4 into 3 I said, no, 12, 4 into 0, 0. So like that, fixed ratio into key row, you have to multiply with all and just write down here. Okay, then what you have to do, a minus b, if you do, you will get this. Okay, and this is the value of this s1. So see, that's what is written, 248, then 3, then 0, then 1, then 0, then 4, 0, 4. Okay, written just like that. For a1 also you have to do. Okay, just like that for a1 also you have to do, in which a, for getting the value of a, you go back to the previous table, that is first table, value of a1. See, from quantity till a2, same thing, just copy paste, 2 1 0 0 minus 1 0 1 0. See, 2 1 0 0 0 minus 1 0 1 0. Okay, then for b, fixed ratio into key row. Okay, so what is the fixed ratio here? 0. Key row, these numbers are there, right? This, which one marked, so it is 0. Obviously everything will be 0, so that's why everything 0. So a minus b, we got this number, just copy this and paste it here. Okay, that's it, got it. So up to here we got it, right? Then Cj is nothing but that what is it, profit function, the coefficient of the the coefficient of the objective function. Okay, this thing only I'm telling, this coefficient of this objective function, this is the coefficient of the objective function. So that's what we have to write down, 62,000, 1,24,000, 0 0 0 minus m minus 1. That's what it is. 62,000, 1,24,000, 0 0 0 minus m minus 1. Then what is Zj? Same thing how I said. Okay, hide this quantity, take x1. Where is that? Hide this quantity. For example x1 is there, so 0 into 3 plus minus m into 1 plus 1,24,000 into 0. Okay, so all together you have to write down here, here. Okay, so see, because here also 0, here also 0, then ultimately only minus m into 1, that's why minus 1. Okay, like that for each you have to do, profit into x1, profit into x2, profit into s1, profit into s2, like that for each you have to do. Need to put note down here. Okay, then Cj minus Zj as the usual step. Okay, Cj minus Zj, so see, 62,000 minus m, it will become 62,000 plus m. Okay, 1,24,000 minus 1,24,000, it will become 0. So like that you have to just deduct you will get this value. Okay, so now we have to see maximization problem, and still some values are positive. Okay, see, still some values are positive until all the values are not becoming 0 or negative. What happened here? Until all the values are becoming 0 or negative, you have to keep on proceeding. Okay, so see which one is highest. See, it is 62,000 plus amp. We are having a highest number with this, so obviously this is the highest, higher than this. Okay, so this is incoming variable. Again select this. Okay, so we got the incoming, we got it. For outgoing, we have to find the replacement ratio. The replacement ratio, how? Quantity column is there, quantity divided by key column. So 240 divided by 3, 2 divided by 1, 3 divided by 0. Okay, so why is 0 we are not selecting? I already told, because if we are selecting this, there will not be any replacement at all, because the replacement ratio is 0. Something has to be replaced, then only some improvement will happen. That's why we are not selecting this. We are selecting the least is 2. Another least is 2. Okay, that's why we are selecting this. So now the outgoing variable is a1 here. Okay, outgoing variable is a1 here, and see where it is crossing, here it is crossing. So the key number is this one. Okay, then fixed ratio is nothing but key column number divided by key number. So 3 divided by 1, 3. This is outgoing, no? So for this no need to find out, so dash. So key column number divided by key number, 0. Okay, that's it. Just like that we will proceed for third table. Okay, just like that we will proceed for third table. See what I said, incoming new variable is easy, continuing variable is difficult. So which one is new? Which one is new is coming here? x1 is coming new at the place of this one, a1. So see, s1 is continuing, x1 is coming new, x2 is continuing. Second. Okay, so fine. So x1 is coming new, and profit, how much it's giving? Go to the objective function, 62,000 it's giving, 62,000. Keeping idle will give 0. x2 is giving 1,24,000. Okay, now see, okay, new variable, just go to the previous table, that key column divided by key number. Okay, it's 2 divided by 1, 1 divided by 1, like that you divide everything, so you'll get this number. Okay, then for finding out the values of s1 and s2, s1 and x2, you have to again do the a minus b formula. So same is done there. So s1 is there. See, a for before s1 whatever quantity is there, no, just copy this and paste it here. One second. Yeah, okay. So for getting this s1, just go to the previous table. For this third table you are finding out, no, go to the previous table, means second table. Before s1 what is there, this full thing just copy and paste here. Okay, then for b, fix the ratio into key row. So see, fixed ratio into key row. So what is this? 3. So 3 into 2, 3 into 1, 3 into 0, like that you have to just multiply. You see, 3 into 2 was first, now 6, 3 into 1 was second, so 3, like that just multiply and you will get this value. Okay, then a minus b you will do, you will get this value. Just copy this value and paste it in the new table, that is third table. Got it? Just like that do for x2 also. x2 also do the same thing. Go to the previous table, means go to the second table. Now we are finding out the third table, means obviously you have to go to the previous table, means second table. x2, copy this, paste it here. Okay, then for b, fix the ratio into key row, fix the ratio into key row. So sorry, fix the ratio is how much? 0. Key row, whatever something is there, fix the ratio is 0, so everything will be 0. That's why everything is 0 here. So then a minus b, you get this, just copy and paste it here, third table. Okay, got it? So we got this, we got this, we got all this. Okay, then once you have, every time once you have reached up to here, no, up to here, next thing is CJ. CJ is nothing but that thing which has no profit. So 62,124 000 minus m minus m. So that's what again, 62,124,000 000 minus m minus m. Then ZJ same way, hide the quantity, x1 0 into 0 plus 62,000 into 1 plus 124 into 0. That's why ZJ is coming 62. Okay, likewise, like how you done for this one, like that only do for x2 also. Profit into x2, profit into s1, profit into s2, s3, profit into a1, profit into a2, like that you do for all. Then CJ minus ZJ, you'll get this. Okay, now you see which anything is still positive. Yeah, still positive is there. Okay, so what it is suggesting, the highest number. Okay, I didn't tell you why we are always selecting highest number, because it says if you are selecting this one, you can increase your profit by this much number. That's why obviously we would like to increase our profit by maximum. Okay, if we are selecting S3, we can increase our profit by 1,24,000. If we are selecting S2, we can increase our profit by 62,000. If S1, we cannot increase 0. X2 nil, X1 nil. Okay, if even then that's it, it will go in minus. A2 minus. Okay, that's why we want to select this, which is highest, S3. We select this. Okay, we got incoming, mark this key column. Okay, now we have to find out the outgoing variable. For finding out outgoing variable, we have to find the replacement ratio. Our replacement ratio, quantity divided by key column. So 242 divided by 4, 242 divided by 4, wherever it is coming like this, no, in fraction, I mean it should not coming points and all. If it is coming like this, then keep it like this only. Don't divide like 240 divided by 4, it's coming how much? 60.5. Don't put in points and all, keep it as it is. Okay, but for example it's coming like 8 by 2 is equal to 4, that time you don't put 8 by 2 and all, that time you make it full. 8 by 2 is equal to 4, like that you put. Okay, that's it. So this you got like that. 2 by 0 0, 3 by minus 1 minus 3. So what I said, least positive number. So least positive number 0, obviously we cannot select because nothing will improve. Least, this least but not positive. So least positive is 240 by 4 only. So this will select as outgoing variable. So as when select as outgoing, mark it. Okay, marked it, that's it. Now we have to find the fixed ratio also. Fixed ratio is nothing but key column number divided by key number. So 0 by 4 0, minus 1 by 4 minus 1 by 4. Okay, that's it, done. Now we'll go to the fourth table. Again same FR program profit quantity x1 x2 s1 s2 s3 a1 a2 rr. Okay, s3 idle, no, 0. x1 62,000, x2 1,24,000. Same thing, we will go to objective function and find out the how much profit is giving. Okay, then again what I said, incoming new variable is easy, continuing variable is difficult. So which one was incoming here? See, s3 was incoming. Which one is outgoing? s1 was outgoing. So in the place of s1, what has come? s3 has come. Okay, so this is a continuing variable. So how you to find out this key row divided by key number? So 242 divided by 4, 242 divided by 4, 0 divided by 4, 0 divided by 4, 1 divided by 4, 3 divided by 4, like that you have to do. So see, 242 divided by 4, 242 divided by 4, 60.5. That's what is taken here. Okay, like that. Then 0 divided by 4, 0 divided by 4, 1 by 4, 3 by 4. See, hope you are understanding, right? So like that you will find this one. Okay, then x1 and x2 will make this table a minus b for x1, a minus b for x2. Okay, see, for a, just go to the previous table. What is the corresponding number? Copy, paste there. Okay, then for b, fr into key row, fixed ratio into key row. For x1, fixed ratio is 0, key row is this one, 0, so obviously everything will come 0. That's why everything is 0. So a minus b, you get this. Now you copy and paste it here, x1. For x2, a, go to the previous table. What I said, x2. Okay, x2 is here, right? So the number, we copy this one and paste it here. Then for b, fr into key row, fr into key row. If you multiply with each, no, you will get this. Then a minus b, you will get this. And copy this and paste in the table. Then cj, as usual, how I was telling all this time. So 62,000, 1,24,000, 000, minus m. Then zj, same way, profit into x1, profit into x2, profit into s1, profit into s3, and then m with a1 with a2, you'll get zj. Okay, then cj minus zj, deduct it. Okay, so after deducting, you see this is 0, 0, this is minus 31,000, 0, this is also negative, this is also negative. So simplex says that everything has become negative or 0, hence this is the final solution. No need to find out RR, no need to find out FR. So what it's saying, keep 60.5 quantity of S3, keep 60.5 quantity as idle, then produce 2 units of X1, 63.5 units of X2. Okay, that will give maximum profit. So if you do, say, 62,000 into 2 is equal to m plus, then 1,24,000 into 63.5, 78,74,000 m plus 78 79,98,000. See, the profit is 79,98,000 maximum. That's what is. Okay, that's it. End of the answer. See, everything is same, only how they have done. Only thing is that they have presented in different way. You should understand each number and then you can do in any way. That's it. Thank you.